This mortar and pestle turning project is unique because it features spindle turning, in-grain hollowing, as well as bowl turning. Typically, in a turning project, we focus on the grain running in one particular direction, spindle, bowl, in-grain. But in this project, each piece, the grain runs in a different direction, and so we need to approach it differently. The best way to wrap your mind around what's going on at the lathe with a piece of wood is to think about a bundle of straws. Wood is simply a bundle of straws. This bundle of straws represents a typical tree where the grain is running the length and it has a certain diameter. Now, if we mount a typical spindle blank between the centers of the lathe and turn this round, that's spindle turning. We're working on the edge grain, and then we'll cut across the end grain. And when we do that, we will cut towards the center because we need the stability of the grain underneath it to support each fiber. If you try to cut backwards away from the center on a spindle, you'll tear the grain just like these straws bend. When you bend wood fibers like this, they break off and you get torn grain. The only solution to torn grain is to cut down below it. You can't ever put it back on. The pestle is a simple spindle. The mortar is actually a spindle as well. The grain on this is running parallel to its axis, so the outside of this is turned really the same way you would a spindle. The difference is that when it's hollowed, we have to think about the most appropriate way to hollow that end grain. And so if we go back to the bundle of straws and think about how would we create a hollow in here, I'll do one with my fingers to kind of represent it. If I cut from the outside in, I'm going to have a hard time finding my way in between each straw, and it's going to push several straws out of the way. What I really need to do is I need to be able to go down inside and come back out towards the outside. Then if I have a sharp tool, I can cut that cleanly. The problem is that just as the back of my finger hits what's left on this other side, that's what would happen with a typical turning tool. So the best solution for hollowing end grain is to scrape it. We don't rub the bevel, we just scrape it away. And there's a lot of different tools that you can use to accomplish scraping. When you get to the base now has grain that runs perpendicular to the axis of the lathe. So now the grain is running in this direction. So as this is spinning around, I have to think about which way that grain is going, and if I want to create a hollow, if I try to go into the center and come out, I'm going to face that same problem I did hitting the end grain and wanting to break it off. If I cut from the outside in towards the center, I have stability underneath each piece that I cut off. There's another grain underneath to support it, and I can make clean cuts from the rim towards the center of the bowl. What I've done as a little illustration for myself is I've made a spindle blank here where the grain is running parallel to the axis of the lathe, and I've marked that in red. Then I've turned a cove. And to turn a cove, it's like scooping sand. I'll turn down the grain so that I'm not breaking grain off of the edges. And I work down to the bottom and stop on each side. And this seems to make a lot of sense to my mind whenever I'm doing a spindle. However, when I turn it sideways and now the grain is running perpendicular to the axis of the lathe, if I want to create that same cove shape like the inside of a bowl, I need to cut from the rim towards the center. So this little visual helps me determine which way to cut for the given grain situation. I've done the same thing here on a bead. So I've taken a block of wood where the grain is running parallel to the axis of the lathe, and I've marked that. I've turned a bead. To turn a bead, I'm going to cut downhill in terms of grain, cutting the fibers cleanly, and I've marked that in blue. But then if I'm going to turn the outside of a bowl, I need to think about which way that grain is going. Because the mortar, the grain is running the same direction as a spindle, I turn the outside just like a spindle, from large diameter to small. On a typical bowl, where the grain is perpendicular to the axis of the lathe, if I were turning the outside, I would need to make cuts that go from the center out in order to shape the outside. This is where it gets a little backwards in my mind. However, making a simple little visual like this and keeping a bundle of straws around helps me remember which way to cut for the given grain situation. So to turn the pestle, it's a spindle. The grain is running parallel to the axis of the lathe. So I'm remembering my bundle of straws visual as to how to approach this. I'm going to start with a block of wood. The grain is parallel to the axis of the lathe. I've marked the centers. I'll mount that between my center points. And now I'll turn this as a typical spindle. So to turn the pestle, it's just a spindle. I've got it mounted between centers. I'll use the spindle roughing gouge. First make it round. By sizing my blank to 1 3/4 inches, I know that when the blank is round, it's 1 3/4 inches round. I need to make the right end of this smaller, 1 1/4 inches in diameter. And right here at the midpoint that I marked needs to be 1 inch in diameter. That makes a pretty quick gauge for the right hand end. This needs to be 1 1/4 inches. Now I can use the spindle gouge to reduce all of this in between. Now I can mark all my critical points. I've already done the midpoint. ½ inch on each end, that's waste material. Okay, so I need to go 1 inch and 1/8 from the right, and 1 inch and 3/8 from the left. I'll use the parting tool to reduce the waste here at the end. Now switch to the spindle detail gouge to form the hemisphere here. It's just half of a bead. Eventually going from the pencil line to the parting cut. The same thing on this side, from the pencil line to the end. And the template. While I haven't done the entire shape, I can lay it on top and I can look over the top and see if the ends match up pretty well. Those look pretty good. Now there's kind of a large cove in between. Great spot for the spindle roughing gouge. Works well if you've got a big broad cove like this. Just using that parting cut in the middle as a little bit of a guide as to how deep. I'm going to go slightly past it, but gives me a good idea of where I want to go. And from the pencil line, it does start as kind of a bead, and then it rounds the other way and becomes the cove. You may find it easier to switch to the spindle detail gouge for the transition. The template is a guide, not very critical though. Just looking for something that's good fitting in the hand and pretty spherical on the ends. I'll remove just a little bit more here. The smaller spindle detail gouge tends to leave tiny little U's. The broad shape of the roughing gouge helps make a little smoother, broad cove. And that's pretty good there. Now I'll work the ends down just a little bit more. So just a quick pass with sandpaper. If I switch to a skew, I can pare the ends down just a little bit smaller, save the amount of handwork that I have to do later. And then you can take a handsaw or even just snap them off. Then just touch up the ends by hand. So I've mounted the blank for the mortar between centers, and I've also marked 5/16 of an inch from the top edge. This will be the top of the mortar. I've marked a line that goes all the way around the blank, and this small section is going to remain square. The rest will be turned. So the first step is to create a pommel, which is the transition in a turning from square to round. It looks a little strange here because we're leaving so little, but it's still the same process. We're going to do this with a spindle detail gouge. I'll start well to the right of my line, and I'll make subsequent cuts to the left, getting closer and closer to the line. To make this cut, I'm going to put the bevel of the gouge facing in a straight line forward. So I'm just eyeballing that that's pointing straight ahead. I've got the flute rolled over so it's almost completely closed off, and I'm just going to lift the handle. When I lift the handle, I'll begin cutting just a little bit into the wood. Now I'll retract the tool by lowering the handle. I'll move slightly to the left, and I'll do the same thing again. With each cut, I will get closer to my line and deeper, closer to being a round piece. As you get close to your line, stop and check frequently to see how close you are to making it fully round. So I've still got a good bit more to go in terms of diameter, and obviously ½ inch or so to the line. And I'm looking for it to be consistent thickness. It actually tapers just slightly, which means that I've started with the gouge a little too far to the left, and then it's gone slightly to the right. I had it angled slightly to the right. So I just need to bring the handle of the gouge over slightly, start the same spot, and go all the way down. So with the pommel complete, I now want to round the rest of this blank. Now while the general shape of the mortar is a bowl, and this is rather short compared to its diameter, much like most bowls, the grain on this is running parallel to the axis of the lathe, so I treat turning this exactly like a spindle, even if it was longer. So to round this out, I will be using a spindle roughing gouge. The spindle roughing gouge can be used any time that the grain is running parallel to the axis of the lathe. And with the corners on the roughing gouge and it rolled to one side, I can work right up against the pommel. So I'm being careful not to hit the pommel, but I can work right up next to it and round the entire blank. Now I'll mark the length, 2 inches from the top. With the length marked, I can use a parting tool to part down and define the overall height of the mortar. Now this is a fairly deep part, so the rest of the material to the right is waste and used for chucking. So I'll use a wider parting tool and remove some of that so I have less friction. And my chuck works at about 2 inches as well, so I'll make that a similar size. Now I'll switch to the spindle detail gouge, and it'll just turn part of a hemisphere. It's kind of like turning part of a bead here. I'm going to work slowly. I'm going to stop and use my template frequently and see how closely I'm matching this profile. The closer I match this profile, the easier it is to make the two parts nest together. If it doesn't match the profile, then it's a guessing game trying to make it fit the base. That's got a good match. Now I just need to sand. So with the mortar sanded on this side, I'll take my little tab template. I'm going to line up the center line with the corner and just trace around it. And there we can see the circular tab that we'll be cutting later. All right, so I've mounted the mortar in the chuck with the tenon that I created earlier. First I'm going to draw a circle for the outside diameter. That's 3 7/8. Kind of prefer using the compass for this instead of turning the lathe on and doing it really for two reasons. Number one, it's right next to that outside edge. It's easy for the pencil to slip off and break the lead off easily. And the second reason is this face is just saw cut smooth, so it may not be dead flat, but it's going to be close enough for the finished project so we don't actually have to turn it. So with that circle done, then I'm going to draw another circle. So now I'll draw another circle. Don't mind the mistake when I set the compass wrong. And this will be the opening of the mortar. It just gives us a guide as to how far to hollow. And then to help with the hand shaping work later, I'll use the same little tab template. Got it aligned on the center line. And I'll draw that tab shape on this side as well. And that'll just help me shape it. So to hollow the mortar, it's in grain. So that grain is facing me, those bundle of straws. So I need to be able to go into the center and then sweep coming out. So I'm making a scraping cut. The spindle detail gouge is great at this. It's very versatile. You just leave the flute horizontal, press in slightly, then rotate the flute to the side, and swing the handle, working out towards the rim. The same process can be done with a scraper because the whole cutting action is scraping. And in fact, I will use a scraper for the finished cuts. I'm able to get just a little bit finer cut with a scraper. But with a spindle gouge, I can be a little more aggressive and remove that wood just a little bit quicker. If I tried to cut in from the rim, I'd be pushing against the grain and it would fight back. The depth and shape of the inside of the mortar is a lot less critical than the rest of the project. Generally, I'm looking for a depth of about 1 5/8 inches, 1 3/4. We're about 1 3/8 so far. Now to make my finishing cuts, I'm going to use a scraper. Any round nose scraper will work. This is just a traditional round nose scraper, just rounded on the end, made out of rectangular bar stock. And this will work. You can hollow in grain with this. You can make your finishing cuts. You can make your roughing cuts with this as well. But the thin bar can be a little flexible. You can get a little chatter. And because it's held flat to the tool rest, it doesn't leave as clean a cut as if you tip the tool. So if you take the same scraper and tip it over on its edge, you can create a shear scrape, which is just a little smoother scrape. The problem is now I'm resting the tool on its corner, which tends to dig into my tool rest. It doesn't move very smoothly. It's kind of tippy. So my preference is a scraper. It happens to have a cutter mounted to the end of it, but it's made out of round bar stock, so it's completely round. The one that I'm using here is high-speed steel. The cutter is high-speed steel, but they make these in carbide, and carbide works just fine as well. But with the round shaft, I'm able to rotate the cutter and get a nice shear scrape just for those last few finishing cuts. The round bar stock tends to be a little stronger, hanging out over the tool rest a longer distance. And I find the replaceable cutters easy to work with. The high-speed steel ones you can sharpen yourself. And when it gets dull in one spot, just rotate it to a new, fresh position. And with the corners and everything on here, I don't like to stick my fingers inside while it's rotating. I like to stop. That feels pretty nice. Now I'll just sand the inside. Again, I'm choosing power sanding. Being very careful though with the corners. I don't want to get my fingers anywhere near the rim of the bowl. Looks good. So now to cut the rim of the mortar with the tab, I'm going to place it face down on the bandsaw, so I've got a good solid registration surface. I can just follow the pencil line as well as the outside of the bowl. Now back to the lathe for a little handwork. So I've mounted the piece back in the chuck. This just works as a nice vise to hold it. And I'll just start with a rasp, eventually switch to sandpaper, and I'll just work this rim down by hand. I can use my pencil lines and the curve of the bowl as a gauge. So after completing the handwork, shaping this outside, getting the tab smoothed up nicely, I'm ready to turn off the bottom, make it flat so it'll sit nice, and get rid of this waste here. To do that, I'm going to use a jam chuck. So I've taken a scrap here, I've put it between centers, turned it round, and put a tenon on it that'll fit into the chuck. Now on the end of this scrap, I'm going to turn just a dome shape, something that roughly matches the inside shape of the mortar, although it's not critical that it matches perfectly. This scrap piece is a spindle. The grain is running parallel to the axis of the lathe. So while I'm using a spindle detail gouge, the important thing is that I'm working from large diameter to small so that I cut across the grain cleanly. And that has a similar shape. Again, it's not important that it matches perfectly. We're looking for surface area here for a jam chuck in this case. So now, I've already finished the inside of the mortar, or already sanded it. I haven't applied any finish. But I don't want to mar up the surface. So I'm going to use a paper towel. I've just got a couple of layers here. Just going to place the paper towel in between the jam chuck and my piece. Push that on there. That just gives a little bit of padding. I'll bring the tailstock up. I already have the center marked from when I turned this originally, between centers. And just press the tailstock against there. So it's jamming the tailstock against the mortar, against the jam chuck, into the headstock, and that's what's going to provide the drive. You want to make certain, though, because you do have this tab swinging, you want to stop, adjust the tool rest with the lathe stopped, and then make sure that it does clear by hand. Nothing's going to touch. I think I'm just touching my live center. That way I'm not touching anything. Everything's clear. I'll use a parting tool to remove most of this waste. If you notice the piece slipping any, you'll need a little more pressure from the tailstock. Also, depending on your lathe, sometimes the quill works itself backwards, so locking the quill helps to prevent it from loosening up as you're turning. Now, while I could use the parting tool to flatten that bottom, the surface is a little rough. And to smooth that up, I can get a cleaner cut with the spindle detail gouge. I'll cut across the end grain. I've got the bevel pointed straight across. Then I need to lift the handle. And I continue lifting the handle as I go towards the center. Then I can turn the gouge over, do the same thing just at an angle, working the waste down in kind of a cone shape to give myself access. Flipping the gouge back over. Just lifting the handle. And getting the bottom as small as you feel comfortable. I'm okay with, on this piece, probably 5/16. Then I'll check with a straight edge. I've got just a little bump in the center. It's not going to sit flat. I'd actually like that slightly concave. So I'm going to angle my gouge in ever so slightly. Make one real light cut all the way from the outside. That looks good. I can see just a little bit of light in the bottom. Everything feels good, looks good. Move the tool rest when I sand so I don't get my fingers close there, and just do a little light sanding on the bottom. Well, at the bottom sanded up, I can remove the tailstock, pull that out of the way, and I can actually hold it on the jam chuck here and just use a handsaw just to remove the little nub that's left, and then finish up the bottom by hand. So I've marked the center of the base here on the top. I've extended this center line all the way out to the corner. Then I've drawn the circle. This will become the opening. That's a 3 7/8 circle. And then I've also marked 1 3/4 inches from the center out. And that's where I'm going to drill this 1.5 inch hole with a Forstner bit. I'm going to drill it about 1/8 of an inch deep. So I've got a fence set up here that I can clamp it to. I think that is 1/8 of an inch. Looks good. Now I just need to glue it to our glue block. To mount the base for turning, I want to attach it to a glue block. This project lends itself well to just starting with a block of wood that's smooth on the bottom, finishes up smooth on the bottom when we're done. So gluing a block to it is really the best way to mount it. I've already got a scrap here I can use as a glue block. I'm just going to take a parting tool, get rid of this rounded portion. Now, while that is flat, it is pretty rough. The parting tool is always going to leave a rough finish. I'd like a smoother surface for glue. So I'm going to take the tip of the skew, flatten this off with a nice smooth cut. Now I don't have all that torn grain. Make a better glue surface and check it against a straight edge. It is good and flat. Now I can glue the base onto here. So now I want to mount this base block to this waste material just to hold it so I can hollow it out. And I want to mount it so that it's secure, but at the same time I can remove it later and just clean up the bottom of this. I don't want to have to do a lot of work there. So a good option here is called a paper joint. And so we'll just use a piece of just craft paper or packing paper, just that brown thin paper, works really well. And what I'm going to do is I'm just going to put a little bit of glue on my blank. Just kind of approximating the center area here. Then I'll put a little bit on the glue block as well. And then the paper in between, I just cut it a little bit larger than my glue block. Just stick it on there. I'm going to use the lathe as a clamp and to make sure that this lines up. It's already flat and parallel on both sides. I've got a center point on the other side that I can use with the tailstock. And I can press the two together, lock the tailstock in place, then use it as a clamp. And also as a sanity check here, just to make sure that you're in the center, you can put your tool rest up. You can adjust it real close to a corner. And then you can check that each corner looks the same, just to make sure that you got the center. Then just let that glue dry overnight. Like with any bowl, I start out pointing the bevel into where I want to cut. Then as I swing the handle, that changes where the bevel is pointing. And as I get to the bottom of the bowl, at the center, the bevel that's on the very end of the gouge is now pointing across the bottom, parallel to the cut I was making. I constantly keep that in the back of my mind to ensure that I'm swinging the handle correctly. If I stop swinging the handle partway through, then I'll stop rubbing the bevel at the bottom. My right hand has all of the control of the tool. I initially adjust the flute open to about 45 degrees by rolling the gouge. I push with my right hand to hold the bevel against the wood, and I swing with my right hand to create a curve. The only thing that my left hand does is keep pressure down on the tool rest. So I've got a little more to go in depth. I'm almost there in diameter. Pattern rocks a little bit, so touching towards the side and it rocks towards the bottom. So wherever the pattern is touching, which is about halfway through the curve, that's really where I need to remove material. And I can actually feel there's kind of a bump. It actually has kind of a straight side. It curves. There's kind of a diagonal. And then you hit another little curve as you go towards the bottom. I really want a nice, gentle curve. So I'll pick that up with the gouge, laying it on the back of the bevel, swinging the handle away from me until it begins to cut where I want to begin cutting. Then I hold the bevel against the wood. I'm now pressing the bevel against the wood, swinging the handle towards me to create the curve that I want. And ideally, I should either run out of wood or, yep, as I get towards the center, I run out of wood. Definitely fitting much better. Still a little more to go in diameter or in depth. I'm getting close to my pencil line. So I'll use the mortar itself to see how everything's going to line up. I really want to remove the pencil line is about where I want to stop my cut. It gives me an idea there as to how close, and try to fit it in. It wants to stop going in part way, so still a little more to go in diameter. So the last few cuts, I'll test fit both the template as well as the actual mortar. To get the best fit possible between the two. Just a whisker of a pencil line left in spots. Still got a little bit of depth to go. See how that's fitting. And we can see it's fitting. It actually fits just there at the rim, just does fit. But it does bottom out, and it doesn't seat all the way down in there. So the sides are kind of vertical for a little portion, so I need to go a little bit deeper and remove more towards the bottom. The diameter looks pretty good. So I'll start inside just slightly. Template's just almost spot on. May need to go a tiny bit deeper. The curve is nearly perfect. And it does seat. And the tab seats. So while it doesn't match the template perfectly, that does match the mortar nicely. And instead of taking another cut, I think that looks good. I've got a clean cut. So now I can sand the inside of the base. So with the base complete, to remove the glue block from the paper joint, it just takes a chisel and a sharp blow or two right on the glue joint, pulls it right off.